Good morning, students. Today we will start with the new chapter, that is chapter name is motion. So as already we discussed or studied in the higher primary, that is in 8th standard and 9th standard. So here we little bit elaborated in this chapter, right? So motion. So before going to study the motion, first starts with the topic, that is point object, right? So while you are going or while you are traveling or while you are moving from one place to another place through a bus or some other vehicles, then while studying the motion, the dimensions of the object are considering as negligible, right? So that objects are called as point objects, right? So while studying the motion, there is no use of the dimensions of the objects, right? For example, bus, it has a finite dimensions, but while studying the motion, there is no use of those dimensions. So considering that bus as a point object, right? So what are point object means? While point objects are those. So what are point objects means? Point objects are those whose dimensions are negligible. So comparing to that of the distance we are traveling. So that one we call as point objects, right? So point objects, here we are neglecting the dimensions of the objects. So while studying the motion, right? So that objects we call as point objects, right? So next, rest. So what is meant by rest? That is, the position of the particle does not position of the particle or object does not changes its place with respect to its surrounding as time passes, right? So for example, this board is there, right? So this board is, we say that this board is at rest because it does not changes its position and its surroundings with respect to time. So as time passes, the board where we placed, so it will be in the same place only. So then we say that this board is at rest, right? So what is rest means? The position of the object or particle does not change its position with respect to its surrounding as time passes. So that one we call as rest, right? The position of the object does not change, the position of the object does not change with respect to surrounding as time passes. As time changes, the position of the object does not changes with respect to its surrounding. So for example, if you place a book on the table, that one becomes, the book is at rest, right? Example, book on a table until we will disturb that book, right? So that one we call as rest. That is, the position of the object does not change with respect to surrounding as the time changes, right? So that one we call as rest, right? So for example, book on the table or any object which are placed on the table, right? So next, motion. So here it is opposite to that of the rest, right? So the position of the object changes with respect to its surrounding as time passes, right? So that one we call as motion, right? The position of an object changes with respect to surrounding as time changes, right? So this is the definition of the motion, right? The position of an object changes with respect to time. As time changes, the position of the object is also changes with respect to the surrounding, right? So that one we call as motion, right? So for examples of the motion, for example, a bird is flying in a sky, right? So this is one example. Or any moving vehicle. So train is moving on its track. So these are the examples of the motion, right? So the rest and motion both are relative terms, right? Right. So rest and motion are relative terms. So rest is the position of the object does not changes with the surrounding as time passes, and motion is the position of the object changes with respect to surrounding as time changes. So these two terms are the relative terms. So relative means, for example, if we consider while we are traveling in a train, so for the co-passenger we are at rest, right? So as time train is moving, for the co-passengers we are at rest, but as an observer is standing outside the train, for the observer the train is moving. That means those two passengers are in motion, but the co-passengers relative to each other, those two are rest, right? So for that reason we call the rest and motion are relative terms, right? So this is the example for the relative terms, right? So next, types of motion, right? Types of motion, right? So in the first one is one dimension motion. So if an object moves in any one of the coordinate axes, then that type of the motion we call as one dimension motion. So what are one dimension motion means? Any object which is moving in any one of the coordinate axes, right? Any one of the coordinate axis out of three coordinate axes, the object is moving in one coordinate axis, right? So that motion we call as one dimension motion, right? So an object moving in any one coordinate axis, right? So an object is moving in any one of the coordinate axis along straight, then that motion we call as one dimension motion, right? So for example, train is moving on its track, right? So this is the motion which is along x-axis, right? So the train is moving along x-axis, right? So this is one coordinate axis, right? So an object is train. So train is moving along the x-axis, right? So that type of motion we call as one dimension motion. So one more example is freely falling object. So if we consider any one object is freely falling nothing but if we left this cap means it will follow the freely falling path. That means any object which is falling freely, right? So here the object follows the which coordinate axis? Y coordinate axis, right? So this one is the object which is falling freely downwards. So here which axis it is? Y axis. So it follows only one coordinate axis. So hence these types of motion we call as one dimension motion. Right? So here we have two examples. One is along the x coordinates and another one is along y coordinate. That is any object which is falling freely. Right? So that one follows the y-axis and any vehicles which are traveling in a straight road, so that is along x-axis. That is along horizontal and this one is along vertical. So any object which follows either horizontal axis or along vertical axis. So that type of motion we call as one dimension motion. Or we say this one and motion in a straight line. We call one dimension motion in another name, that is motion in a straight line, right? So next one is two dimension motion. Two dimension motion. So this one is the second type of the motion. Two dimension motion, or we call this one as motion in a plane. Right? So other name for the two dimension motion is motion in a plane. So here an object moving in any two coordinate axes, right? So this one we call as two dimension motion. That is an object which is moving in any two coordinate axis. That means it can take either xy axis or it can take yz axis or it can take xz axis. That means in a coordinate system we have three axes, right? So out of three, here the object is taking two coordinate axis, right? So here we have x axis and here we have y axis, right? So example, if we kick a football, then the ball follows the two dimension motion, right? So when we hit a cricket ball, so that ball also follows the two dimension motion. That is, the ball will travel both in x axis and along with the y axis, right? So for that, like this, right? So if we hit any ball means initial, this one is the coordinate x1 comma y1, so it will reach to here means it will take x2 comma y2. That means the object follows the position change along x-axis and also along y-axis. So if you observe here, the position which is changed along x-axis is x1 here, and from here to here it changes the position is x2, right? So similar way the position of the object changes in y-axis is here we have y1, so here we have y2, right? So we have change in position in x-axis also along with the y-axis also, right? So here an object which follows the two paths, right? That is along x-axis and along y-axis. So two coordinate system, that is two coordinate axes are used in this motion. So hence we call that motion is called as two-dimension motion, right? So example is a ball which is moving. When we kick the ball is moving. That ball we have follows that ball has follows the two coordinate axis, that is x-axis and y-axis, right? So for example, one more example is motion of insect on the flow, right? So motion of the insect will be nothing but, so insect which is moving along the x-axis, so frequently it keeps on jumping. That means it also covers the y-axis also, right? So that one is the example. So better example is when we kick a ball, football or any cricket ball. If we throw any cricket ball, means that will follow the two-dimension motion, right? So the two-dimension motion is also called as motion in a plane. So that one is the second type. So on next, the third one is three-dimension motion. So or we call as motion in a space, right? So three dimension means, so here the object is moving in a free space, that is it uses all the three coordinate axes, that is x-axis, y-axis and z-axis, right? So that type of motion we call as three-dimension motion, right? So any flying objects, right? For example, an aeroplane is moving, so that aeroplane is follows the three-dimension motion. So birds are flying, so that also follows the three-dimension motion. That is an object which is moving in free space. So that type of motion we call as three-dimension motion. That is, it uses the three coordinate axis, right? So object which is moving in, or an object moving in free space, or it uses three coordinate system, right? So that type of motion we call as three-dimensional motion, right? So example for the three-dimensional motion is any flying object. So birds which are flying in space, so birds flying or any kite which is flying, right? So these are the examples of the three-dimensional motion, right? So what is motion? That is, motion is change in position of the object with respect to the surroundings as time passes. So we have three types of motion, that is one dimensional motion. So here we use only the object which is moving in only one coordinate axis. So that one is called as one dimension motion, and the object which is moving in two dimension, that is two axes, that we call as two dimension motion, and the object which is moving in a free space, so that one we call as three dimension motion, right? So these are the three types of the motion, right? So in the next, distance. So what is distance? So distance is the actual path traveled by an object. So that one we call as the distance. That is actual path followed by an object in a straight line, right? So that one we call as the distance. So distance is nothing but the actual path traveled by an object. So between any two points, right? With respect to the, as time changes, the position of the object is also the changes, right? So initially we call the distance is the actual path followed by an object, or actual path traversed by an object. So that one we call as the distance, right? So the other name for the distance is path length. So we call distance or path length both have the same meaning, that is actual path followed by an object, right? So for example, an object is traveling from A to B along x-axis and further it deviated and it traveled along y-axis C, right? So the distance we called is the actual path followed, right? So that means distance or path length that is equals to A to B, right? So first it travels from A to B. So actual path traveled is AB. Next from B to C, that is plus BC, right? So this gives the distance between the 2 points A and C, right? So the distance between A and C is how much? That is AB plus BC, right? So the distance traveled by the object initially, for example, here it covers 10 kilometers from A to B, then from B to C it covers 15 kilometers. The total distance covered by the object from A to C is how much? That is 10 plus 15, that is equals to 25 kilometers, right? So if you observe here, this distance has only the numerical value, magnitude, right? So this distance is only, we have the magnitude along with this unit. So hence distance is a scalar quantity, right? So distance is a scalar quantity, right? The first point, because if you observe in this example, this distance initially it travels from positive x-axis, that is from A to B along horizontal. Later it travels from B to C, that is along vertical. Then the distance between from A to C, the total path covered is 10 plus 15, 25. But here there is no mentioning of the direction, that is from A to C, in which direction it is followed, right? So for that reason, this distance has only the magnitude and it has no direction, hence the distance is a scalar quantity, right? So this one is the first point. Next, the second point is, so distance is always positive. So distance is always positive, right? For this, considering the coordinate axis, right? To know this one, why the distance is always positive, that is actual path traveled, right? So this one is the coordinate axis, right? So 0, here we have positive values along x-axis 1, 2, 3, 4. So in the negative side, in the LHS we have -1, -2, -3, right? So initially the object starts from O, right? So if you consider this one as one vehicle, so this it starts from O, it travels towards the positive x-axis, then it reaches to 3, that is point P, right? So first the vehicle travels from O to P, right? So next it returns back from P to somewhere here, that is Q, right? Now observe here, the first starting point is from O, then it covers the distance, how much distance it is covered. So here 0 to 1, 1, here it is 1 and here it is 1. So distance which is covered from O to P, right? The distance. So in this we need to measure the distance. So distance is the actual path followed by an object, right? So the actual path is from O to P plus P to Q, right? So that gives the distance, right? So here the distance from O to P is how much? It is 1, 2 and 3, right? So OP is 3, right? Next, plus PQ, from here to here the distance covered is, so if you measure from here, so from here to here it covers 1, here it is 1, here it is 1, from here to here 1, here to here 1 and here to here 1, right? So the distance which is covered from P to Q is 1, 2, 3, 4, 5 and 6, right? 3 plus 6. So the total distance covered is how much? That is 9. So if this one is in meters, then the total distance covered by the object is 9 meters. Even though here we have the negative values -3, -2, -1, but we get the positive one because the distance which we are measuring is the actual distance. Hence, distance is always positive, right? So this one is important. Distance is always positive, right? Next, third one is the SI unit of the distance is meter, right? So SI unit is meter, that is m, right? So about distance we have three. One is the distance is a scalar quantity, distance is always positive, and the SI unit is meter, right? This is about the distance. Next, displacement. So what is displacement? So displacement is the distance or which is the actual distance which is measured between the initial and final position, right? That we call as the, what is displacement? So displacement is the shortest distance between the initial and final points or position, right? So what are displacement? So displacement are the shortest distance between initial and final positions, right? This one we call as the displacement. So what are displacement? So displacement are the shortest distance between the initial and final position. So in the previous we considered one example, that is an object which is traveling from A to B, then from B to C, right? So here we need to find the displacement. So this one is the initial position, right? So A is the initial position of the object and C is the final position of the object, right? So A traveled from A to B along horizontal and then vertical from B to C. So here in the definition, displacement is, it is the shortest distance between the initial and final position. So shortest distance is nothing but if we draw a line between the initial and final position, so that gives the shortest distance between those two points, right? If we draw a one straight line from A to C, so this distance gives the shortest distance from the point A to C, right? This gives the shortest distance between the initial point and the final point. So hence the displacement is given as, so displacement is equals to AC, right? So AC is the distance which is the shortest between the initial and final position, right? So if the distance which is covered by an object from A to B is 3, then from B to C is 4, then the shortest distance, so it is in the triangle form. So by applying the Pythagoras theorem, square root of 3 square plus 4 square, that is 9 plus 16, 25. So the shortest distance is how much? That is 5, right? So here 5 meter, 3 meter, 4 meter. Then shortest distance is how much? 5 meter, right? So this is about the displacement. So displacement is the shortest distance between the initial and final position, right? So here the displacement is vector quantity, because here we are giving the direction. So in which direction if we draw the straight line, so that gives the shortest distance, right? So displacement is a vector quantity because it has both the magnitude and along with its direction. So hence that one we call as the vector quantity, right? So this one is the first point. So next, the second point is displacement is positive, negative, and it may be 0. Right? So displacement either positive, negative, or it may be 0. So it follows these three: positive, negative, and 0. Further, considering the similar example, so 0, 1, 2, and here 3, -1, -2, and -3. Right? So taking one coordinate axis, right? So this is in meter, right? Now the object starts to moving from O to P here, right? From O to P. Next, for this case, so considering this one as case 1, right? So here we have three cases, right? Positive, negative, and 0. For that, for first case, displacement is nothing but shortest distance between the initial, this one is the initial, starts from O and ends at P, right? So here the shortest distance we can draw is the straight line, that is OP, right? So final is how much? 3. Initial is how much? 0, that is 3 minus 0, we get 3 meter, right? So displacement is how much? 3 meter. Next, case 2. So it starts from 0, then it travels to P, again it comes back to somewhere here, it is Q, right? So in the case 2, the object starts from O, that means initial point is O. So from O to P it travels, then further it comes back to position Q, that means displacement is equals to, that is by the definition, this becomes the initial position and this becomes the final position, right? So here I will write means displacement is equals to final position minus initial position. So this gives the formula, right? So displacement is equals to final position minus initial position, right? So this one is the initial position and this one is the final position. That means the displacement is between O, Q, right? Displacement here is O and Q, right? So final position value is how much? -3. Minus initial value is how much? That is 0. So -3 minus 0 is -3 meter, right? So in the first case we get the positive value, that is displacement is positive, right? So in the second case we get minus 3, that is displacement is negative. And for the third case 3. So the initial point is O, starts from O, it travels to P, then it travels to Q, again from Q it comes back to O, right? So it starts from O itself. So this is the first case, then here we have the second case, and here we have the third case. So in the first case it covers from 0 O to P, right? So that gives the first case. So in the second case it travels from O to P and then from P to Q, right? So the initial point is O and the final point is Q. Minus 3 minus 0 we get minus 3. So in the third case it starts from O, it travels towards the P and it backs to Q, and again it comes back to the O, right? That means here is the initial position and here is the final position at O itself. That means initial position is 0 and also the final position is 0. So for case 3, displacement is equals to OO. That means 0 minus 0 we get 0 meter. That means the displacement is 0, right? So this is about this point, positive, negative and 0, right? So displacement is either positive, negative or it may be 0, right? Next, third point is the magnitude, that is distance is always greater than equals to magnitude of the displacement, right? Here we have the distance which is greater than of the magnitude of the displacement. That means only the numerical value of the displacement, because displacement is a vector quantity, it has both the magnitude and direction. So here the distance which is always greater than or equals to that of the magnitude of the displacement. Magnitude is represented by the modulus of the displacement, right? So for this, if we consider the same example here, so for distance, right? So here for distance from A to B and B to C, that means 3 plus 4, right? So how much we get here? 7 meter, right? The displacement from A to C is from, distance from A to C is the actual path followed, that is from A to B and B to C. That means 3 plus 4 we get 7 meter, that is the distance, right? So here if you observe, the displacement is the shortest distance between the initial and final position. So that is how much here? 5 meter, right? So in that example only, if you observe, means if you observe here, distance is, the condition is greater than or equal to. So here if you observe here, 7 meter is greater than 5 meter, right? So displacement how much here? 5, and distance is how much here? 7. That means 7 is greater than 5. That means distance is greater than displacement, right? So next, consider here. In the first case, displacement we get is how much? 3 meter. That is object is traveling from O to P. So if we find the distance also here, that is actual path traveled. So from O to P, so how much path it covers means 1, 2, and here it is 3. So distance is also 3 meter, right? Displacement 3 meter, distance is also 3 meter. That means displacement is equals to distance, right? So observe that one. So for that, this is the condition. In the first case, here we have 7 is greater than 5. Here we have 3 meter is equals to 3 meter. So if we combine those two, we can write distance is always greater than or equals to displacement. So when it will be equal means if the object is moving in a straight direction, that is moving in a one dimension motion, both the distance and displacement are the same magnitudes, right? That means distance is equals to displacement when those two are moving in a straight direction, right? So this is about the displacement, right? So in the next class we will discuss with speed, right? So next topic is speed and velocity, right? Thank you.